The topic of today's video is solving limits of multivariable functions. So here we have a function containing x and y, and we're doing the limit as x and y approach 0 and 0. And before I go through with you how we should go about solving these limits, I want to point out that there are 12 days left in the Maths Countdown series that I'm currently filming. So that means I've done 88 videos already, so that's a significant amount of videos and a significant amount of maths that I've already covered. So make sure you check out the rest of the series. I'll link it to this video. Okay, so when we are dealing with limits of multivariable functions, we treat them much the same as limits of univariate functions. So if we had to have just had x approaching a certain number or y approaching a certain number, and then only having one variable in this function, we approach it in much the same ways. And some of the techniques that we'll use to solve limits of these form could be the squeeze theorem, which we use for both univariate and multivariable functions, as well as L'Hopital's rule, algebraic manipulation, as well as many other techniques of solving limits. Okay, so with this particular limit, what we want to do is we're going to use algebraic manipulation and take out an x as a common factor in this numerator. Okay, so we have the limit as x and y approaches 0 and 0 of, now we take out this x, so we have x minus y, and then that's still over the square root of x minus the square root of y. Well, there's something that you should notice here, and it might not be that obvious, but it's necessary to notice it in order to continue. We can actually factor this into the difference of two squares, and the giveaway is this denominator, because that'll be one of our terms. So I'll show you what I mean. So we have the limit as x and y approach 0 and 0 of x into, now we factorize this into root of x minus root of y times by root of x plus root of y, and that of course all over root of x minus root of y. Then those cancel quite conveniently, and then we can see very easily that as our x and y approach 0, this x will approach 0, and this term here will also approach 0. We'll have 0 times 0, and our limit will simply be equal to 0. So I hope you found this video useful and interesting. I'm most likely going to be covering a few other multivariable limits in the coming days, so make sure you stick around to see them. Thank you for watching.